The Electric Grid System by Harmandeep Singh. Introduction. In this video, I will explore why I chose the topic of electric grid system, how the electric grid system impacts our daily life, how does the electric grid function on a broad basis, how we get electricity into our homes, and how do the different concepts from physics that I've learned this semester connect with the electric grid system and the power lines, and why we use high voltage power lines for electricity in our homes and our businesses. The reason why I chose this topic is because as a kid growing up from a young age, I've noticed that power lines exist everywhere. They're very big and exist in very common public places. I've always been curious about how they function and how they help power our homes. I want to know what role they play in powering our homes and everything around us. And I want to be able to analyze the past, the present, and the future of the electrical grid system, and to be able to use what I've learned in my physics class and being able to apply it to what I see on an everyday basis. The previous generation of the electric grid system. Before the invention of the modern electric grid system, electricity producers developed their own system to deliver electricity to homes and businesses. This method had few drawbacks. For example, it was costly, it was inefficient, and it had underused infrastructure. This led to the creation of the modern electric grid system that we have now. It's broken into three main parts, including the generation, the transmission and distribution of electricity, and the consumption in our daily homes. This is how our current electric grid system looks like. It all begins at the generating station. This is where electricity is produced. And from the generating station, the electricity travels to a generator, a step-up transformer. This is where the voltage is stepped up so it can travel over long distances of time via the transmission lines. And the reason why we have high voltage transmission line is because it minimizes the electricity that's lost in transit. The higher the voltage is, the less the electricity is lost. After the electricity travels through the transmission lines, it goes to another substation, which is a step-down transformation. This is where voltage is stepped down to the suitable need of a home or a business. And after this step, it travels through a distribution lines, which is where our homes are hooked up onto, and this is where we receive our appropriate level of electricity. Pros and cons of the electric grid system. Due to the creation of our current electric grid system, infrastructure was shared among the distributors, which led to lower cost, increased reliability, and a centralized the electric grid system. But the con is that some of the electric grid system is outdated. It's a one-way system, and it doesn't fully support the modern electric form of electricity. It doesn't allow the use of small-scale electric generation. The smart grid system. This is where we look ahead to the future. The smart grid system uses technology to have real-time information about energy consumption and production. For example, the system can reduce the energy consumption at peak hours and predict patterns of energy usage to help you better manage your electricity. It gives you real-time feedback via data for shortage, and it allows the incorporation of small-scale electricity generator sources. Listed above on the screen are the sources that I used for my project. Thank you for watching.